We're graphing quadratics. Now, a quadratic is the path that an object follows if it's subjected to a constant force. The clearest, most obvious example of that is a projectile, meaning something that was thrown. So today my class threw footballs straight up into the air, and using video analysis we plotted the trajectory, that is the height against time, and saw that it always forms a perfect quadratic. Now, if you study physics, you learn Newton's second law, the fact that the force due to gravity appears to be constant when your altitude doesn't change much, and a little bit of, let's say, differential calculus, it becomes obvious that you're going to get a quadratic. However, as you're starting out, don't worry about all that. Just know that quadratics are useful, especially when analyzing how something moves in relation to a constant push or pull. So I'm going to show you how to graph the very most basic quadratic, and that is y equals x squared. So we're going to start out, the simplest quadratic we can make is y is equal to x squared. And the way I'm going to plot it is by making some points. So I have an x and a y value, and I'm going to look at minus 3, minus 2, minus 1, 0, 1, 2, and 3. Now, if x is equal to minus 3, y is x squared, so y is negative 3 squared, which is negative 3 times itself, and a negative times a negative is a positive. Remember, if you take 3 backward steps after turning backwards, you're actually moving forward. So that's 3 backward steps, and that's after turning backwards. So we're actually going forward. A negative times a negative is a positive. So negative 3 times negative 3 is positive 9. So negative 3 squared is 9. Negative 2 squared is 4. That's 1, 0, 1, 4, and 9. And now to plot this, we have our point 0, 0. That's right here. Remember, this is the x-axis and that's the y-axis. 1, 1, so that means when we go over 1, we go up 1. When we go over 1 to the negative side, we also go up 1. That's this point here. So I've started at the middle and worked my way out. So that's 0, 0, that's 1, 1, and this is negative 1, 1. Then when I go over 2, I go up 4. So I'm over 2 and up 1, 2, 3, 4. Likewise, I go over negative 2 and up 1, 2, 3, 4, putting me here. And I could continue as I go over 3 in either direction. I'm all the way up to 9, and so on and so forth. So this is what the most basic quadratic looks like. How we get things like a projectile? Well, we put a negative there, that turns that shape upside down. And then by adding in numbers and x's and whatnot, and we'll learn in detail later, you shift things over and move them up and get it to match the actual situation you're dealing with. Okay, we're now going to consider an example where there's a little more happening, but not too much. We've got x squared plus 3. So I'm going to put in the usual numbers, my x value and my y value, which is x squared plus 3, minus 3, minus 2, minus 1, 0, 1, 2, and 3. And let's see what number comes out when I put these x values into this equation. Again, negative 3 squared. Negative 3 squared is positive 9. So I have 9 plus 3 more. So that's a 12. Negative 2 squared is positive 4. Add 3, and that's a 7. Negative 1 squared is 1. Add 3, and that's a 4. 0 squared is 0, but if I add 3, that's a 3. This will be a 4, a 7, and a 12. And when I go to plot this, it's going to look exactly like y equals x squared did. However, everything is going to be shifted up 3. I've got this point here where x is equal to 0, my y value is 3. That's right here. And then over here, when x is 1, y is 4. That's up here. and its mirror image is over here. That's when x is -1, y is 4. When x is 2 or -2, y is 7. So that's 4, 5, 6, 7. That's up here. Now notice this looks just like this one here, except it's been shifted up. And notice even further, it's been shifted up by 3, exactly as is being added here in the equation. So that's y equals x squared, and that's y equals x squared plus 3. That's all been shifted up. So I'm going to do one more example that looks more like the path that you saw a football follows when we throw it into the air and plot it against time. So let's look at y is equal to -x squared plus 7. So again, I'm going to put in the usual numbers here. -3, -2, -1, 0, 1, 2, and 3. Those are my x values. And my y values, which are going to be equal to -x squared plus 7. I'm going to square -3, which gives me a 9. Let me write this out for you. Y is equal to -x squared plus 7, but I'm looking at the case where y is equal to -3. So y is equal to the negative of -3 squared plus 7. Now be careful. Our equation states already that the x squared term is negative. In addition, the x value that's within there is also negative. We're going to slowly and carefully apply our known rules of arithmetic here. -3 squared is +9. So I have a +9 here. That takes care of that bracket, but it's still have that negative there. So it's -9 plus 7, which is -2. So that's a -2. This here is going to be -4 plus 7, so that's +3. This one here is going to be -1 plus 7, so that's a +6. And this is 0 plus 7, so that's 7. This again will be 6, this will be 3, and that will be -2. And you can verify all of these for yourself. I'll pick one at random. Let's look at this one here. When x is equal to 2, y is equal to 3. Because y is equal to -x squared plus 7, and I'm saying when x is equal to 2, it is -2 squared plus 7. 2 squared is 4, so that's -4 plus 7, making it +3 as required here. I'm then going to plot all of these points. When x is 0, y is 7, that puts me up here. When x is 1, y is 6, that puts me down here. Likewise for -1. When x is plus or minus 2, y is 3, that puts me down here. And when x is plus or minus 3, that puts me at -2, which is down here, giving me this shape. Looking more like the path of a projectile. You can imagine if you threw a ball, it would go up and it would come back down. Even if we're not throwing it forward, just straight up and down, and plotting its position as time moves forward.